today I will teach you about chapter 3. Okay, basically chapter 3 is divided into two parts. First is the red law and the second one is the stoichiometry. In this video I will teach you an example of a red law question and the solution. Okay, firstly, this is the question. It's the question about determination of the activation of energy. Is to calculate the activation energy for the decomposition of benzene, dionysium chloride to give chlorobenzene and nitrogen. Okay, basically this is the diagram, and in the question given a table of K and temperature. Okay, firstly, when you have this question, when you get this question, you have to know how to tackle the question. In basically this question have two solutions. Firstly is to use the graphical method, and the second one is to use the Excel method. But I will not teach you how to use the Excel method because we doesn't have to use the Excel method to answer the final exam question. Okay, so our aim is to tackle the solution using the graphical solution. Okay, firstly, when you get this table, you have to make the third row of 1 over t, and then you get the value of 0.00043, 0.00103, 0.0018, 0.00355, and 0.00717. Okay, after you get this 1 over t value, you need to plot a graph of 1 over t and k. 1 over t is the x-axis and k is the y-axis, and then you get a best fit line, and you get the equation from the graph. Okay, so I have obtained the graph from this table. It basically look like this. Okay, as you can see, in the x-axis is the 1 over t, and the y-axis is the value of k. Okay, from the graph I get an equation of k. I get an equation of k equal to 1.32 times 10 to power of 16 exponential of 14017 over 10t. Okay, so from the graph I get this equation. So what you have to do next from the next equation? Okay, from this equation you have to rearrange the equation until you get this form: logarithm of k2 over k1 equals to negative of e over 2.3r bracket of 1 over t2 minus 1 over t1. Okay, from this equation you rearrange until you get this form. In the CD of the textbook you can obtain the solution of rearrangement. Okay, after that, after you get this form, you then make the e as the subject, and you get e equal to negative 2.3 r log k2 over k1 1 over t2 minus 1 over t1. Okay, when you get this equation, you want to find the activation energy, right? But you don't know what is the value of 1 t2 and 1 t1. Okay, then after this, you have to use the decay method. Okay, and by using decay method, we have the relation of K2 equal to 0.1 K1. Okay, and let's say if we choose K2 value of 0.005, then we get K1 equal to 0.005. We get K1 equal to 0.0005 because K2 is equal to 0.1 K1. Okay, after that, if K2 equal to 0.005, then we get the value of 1 over T1 equal to 0.003025, and K2 K1 equal to 0.0005, then 1 over T2 will equal to 0.00319. Okay, we get this using the decay method. And then after we get this value, we have to substitute again into the main equation. Okay, before that, why we choose K2 equal to 0.05 and K1 equal to 0.005? Because in the equation we have this expression, right? Log K2 over K1. So if log 0.005 over 0.0005, we get the value of 1. So we can exclude this expression from the main equation. And then after that, we have the equation of E equal to 2.3 times R times 1 from the log over 1 over T2 minus 1 over T1. T2 we get from this value, and T1 we get from this value. And then using your calculator, you will get the value of activation energy of 116 kilojoule over mole. So basically, this is the solution using the graphical method. Thank you.